All right, so today we're going to do a deep dive into some really cool stuff. Like, when you buy something online, imagine teaching a computer to do that perfectly every time.
Yeah.
That's Selenium. And we're going to go through the top 20 interview questions about this web automation superstar.
Okay.
So whether you're prepping for a job or just super curious, get ready for some aha moments.
That's a great way to put it. Selenium is like you're giving your computer a set of instructions to use websites just like a person would.
The first question in this guide is a classic. What is Selenium? We've kind of teased it out a bit, but let's break it down more.
Selenium is an open source framework, so it's free to use and always evolving, thanks to a giant community of developers. It's also really versatile. It works with tons of programming languages, Java, Python, C#. Whatever language you're comfortable with, Selenium probably speaks it too.
That's awesome. So it's like a universal translator for the web.
Exactly. And it's not just one tool, it's a whole suite. Selenium WebDriver is like the heart and soul, the one that directly controls the browser. Then there's Selenium IDE, which is great for beginners. It records your actions and plays them back so you can make easy tests. And then for the real power users who need to test across multiple machines and browsers at once, there's Selenium Grid. Imagine the efficiency.
This level of automation, this has got to be a game changer for developers. Can you talk about how Selenium integrates into a typical development workflow?
Yeah, absolutely. Think about a continuous integration, continuous deployment pipeline. Every time a developer makes a change to a website, it needs to be tested completely before it goes live.
Right.
Testing on every browser every single time would be like a nightmare. Selenium automates that process, so you save so much time, and it ensures a consistent user experience across the board.
Wow. I'm starting to see why this is like a sought-after skill. Okay, next question sounds kind of technical, but it's really intuitive. Phenylenum versus phenylements. Explain it to me.
Think of it like you're searching for something specific on a web page. Let's say you're looking for that Buy Now button. You know you have a specific description, an ID, and you only want that one element. That's find element. But what if you want to gather all the product listings on a page?
Okay, so that's like casting a wider net.
Exactly. Find elements finds all the elements that fit a certain description. Maybe a particular class name or tag, like saying, find me everything that looks like this, and then getting a list of all the matches, even if it's empty.
So one is targeted, the others for grabbing a collection. Now, what about those tricky dynamic web elements, the parts of websites that are constantly changing? How does Selenium handle that?
Yes, the moving targets of the web. Imagine trying to click a button that keeps changing its position. That's where explicit waits come in. It's like telling Selenium, hold on, let this element load correctly before you try to interact with it.
Like waiting for a video to buffer before you hit play.
Exactly. You don't want Selenium clicking on the wrong thing because the page hasn't fully loaded.
The guide mentions different types of waits. What's the difference?
There's implicit wait. That's a default setting for how long Selenium should wait before it throws an error. Good starting point, but not always sufficient. Then there's explicit wait, which is way more targeted. You specifically say what condition you're waiting for, maybe an element to be visible or clickable. And for even more control, there's fluent wait. It lets you customize how often Selenium checks for that condition and even ignores certain errors.
So waiting strategically is a key part of writing efficient Selenium tests. You don't want your code wasting time waiting for things that aren't ready.
Right. It's all about optimizing the process.
Yeah.
Speaking of optimization, let's talk about one of Selenium's superpowers, cross-browser testing.
Oh, yeah. Ensuring compatibility across so many browsers. That sounds like a logistical nightmare. How does Selenium even make that manageable for developers?
It's all about automation and the magic of drivers. Each browser speaks its own language. Drivers act as translators, so Selenium can talk with Chrome, Firefox, Edge, Safari, all of them.
So you write the code once, Selenium takes care of running it on all the different browsers. That's amazing. No more best viewed in messages.
Exactly. It ensures a consistent user experience no matter what browser they're using. That's the goal.
Totally. Now let's move on to another important concept. The Page Object Model, or POM.
This is a design pattern that's all about organization and reusability. Imagine you're building a house. Instead of starting from scratch every time, you use a blueprint, a plan that defines the structure and layout.
So POM is like a blueprint for each web page.
Exactly. It keeps your code nice and organized, easy to maintain. Instead of writing messy, repetitive code for each element on a page, you create reusable components. This is really helpful when websites update a lot. You only have to change the blueprint, not the whole test script.
The beauty of reusable code. Now, we all see those annoying pop-ups and alerts. How does Selenium deal with those?
Selenium wouldn't be complete if it couldn't handle those. It uses something called the alert interface to talk with these pop-ups.
So it can like detect a pop-up and then tell the browser what to do.
Right. You can accept the pop-up, dismiss it, or even pull text from it to use in your test. Think about testing user flows where you need to like confirm or cancel certain actions. Selenium makes it all possible.
That's really useful. Okay, last one for now, testing on multiple computers at once with Selenium Grid. That sounds impressive.
It is. Selenium Grid lets you spread your tests across a network of machines, essentially creating a super-powered testing team. Imagine you want to test your website on different operating systems and browser combinations.
Right.
Selenium Grid can handle all that easily.
That sounds incredibly efficient. I can see how this would be a total game changer for big companies that need to make sure their websites are working perfectly for everyone. But what happens when things go wrong? How do you debug a Selenium script? Welcome back to the deep dive.
Yeah.
We left off talking about debugging those tricky Selenium scripts. I'm guessing it's not always smooth sailing, is it? Yeah.
No, it's true. Even the most well-written scripts can run into issues. Debugging is all about, finding and fixing those errors. And luckily, Selenium provides some really helpful tools to do that.
Okay, so what's in a Selenium debugger's toolkit?
One essential tool is the breakpoint. It's like hitting the pause button at a specific point in your code. This lets you examine the state of your application, see what values variables hold, and really understand what's happening step by step.
Okay.
Another crucial tool is logging. It keeps like a detailed record of everything that happens during a test, which can help you pinpoint exactly where things went wrong. And then for like visual evidence, there are screenshots that capture what the browser looks like at various points in the test, which can be super helpful for identifying issues related to like layout or the appearance of elements.
It sounds like you need a bit of a detective mindset to be a good Selenium debugger. Have you ever encountered a particularly challenging bug?
Oh, absolutely. I remember working on a script that involved interacting with this complex web application that relied really heavily on JavaScript. And the script kept failing at this specific point. I just couldn't figure out why.
Oh, no.
I spent hours going over the code, like line by line, but nothing seemed out of place.
I feel that pain staring at code for hours can make your eyes go blurry.
Yeah, it can. And I finally had the idea to add some logging statements right before the point where the script was failing. And this let me see exactly what values were being passed to the Selenium commands. And that's when I discovered the problem. It turned out that a critical element on the page wasn't fully loaded when the script was trying to interact with it. The timing was just slightly off.
A classic timing issue. Sounds like an explicit wait would come in handy there.
Exactly. It was a simple fix once I understood the root cause, but it taught me a valuable lesson about the importance of using logging effectively to really gain insights into what's happening behind the scenes.
Logging your debugging best friend. We also touched on Shadow DOM elements earlier. Can you elaborate on those?
Certainly think of Shadow DOM as a way for developers to create these self-contained components within a web page, for example. A custom video player or like a fancy drop-down menu.
Okay.
These components have their own internal structure and styling, which are hidden from the main web page's DOM. It's like having a mini website within a website.
Interesting. So it's like having a secret compartment within a web page. Why would developers use this?
Well, encapsulation is a key reason. Shadow DOM allows developers to create reusable components that are protected from conflicts with other parts of the page. It's a way to keep things organized and make sure that styles and functionality don't interfere with each other. The challenge for testers is that these elements are well hidden. Traditional Selenium commands often can't see into the Shadow DOM.
So how do you test these hidden elements with Selenium?
That's where JavaScript comes in. Selenium lets you execute JavaScript code directly in the browser, giving you access to the entire DOM, including the Shadow DOM. It's like having a secret key that unlocks those hidden compartments.
Ah, so you're basically speaking the browser's native language to gain access. That makes sense. We also briefly mentioned validating broken links. Can you tell us more about why that's important and how Selenium handles it?
Imagine landing on a web page and clicking a link only to be greeted with a page not found error. Frustrating, right? Broken links can damage a website's credibility and user experience, and manually checking every single link on a website would be incredibly tedious, especially for large sites.
Right.
Selenium can automate this process, saving us a ton of time and effort.
So how does it work? Does it just go through and click every link?
It's a bit more sophisticated than that. Selenium can extract all the links on a page and then send an HTTP request to each link to check its status code.
Status code? What's that?
It's like a secret message from the web server that tells us whether the link is valid or not. A status code of 200 means everything is okay, the link is alive and well, but other status codes like 404 indicate a problem, like a broken link or a missing page.
So Selenium is like a website health inspector, making sure all the links are in good working order. That's pretty cool.
It is, and Selenium can even take screenshots of any broken links it finds, giving you visual evidence of the problem. This is invaluable for reporting issues to developers and ensuring that they get fixed promptly.
This has been fascinating. We've seen how Selenium can handle everything from dynamic web elements to cross-browser testing pop-ups, shadow DOM, and broken links. Is there anything this tool can't do?
We've covered a lot of ground, but we've only scratched the surface of what Selenium can do. There are even more advanced techniques and features to explore, but we'll have to save those for another deep dive.
I'm already looking forward to it, but for now, let's take a short break and come back to wrap things up in part 3. Welcome back to the final part of our Selenium deep dive.
It's been a journey exploring this tool.
We've gone from the basics to some advanced stuff like handling dynamic elements, cross-browser testing, shadow DOM, even debugging.
Yeah, debugging. But like any powerful tool, it's not just the features, but how we use it,
It's like having a super fancy kitchen. You could just use it for toast, but it's really meant for way more.
Exactly. Selenium lets us be creative with web testing, push those boundaries, and make sure our websites are not only functional, but robust, reliable, and user-friendly, right?
So for our listener who's been with us, what are some of the key takeaways here?
First thing, Selenium is not just one tool. It's a whole suite of them that work together for a total web testing solution. WebDriver.ide. And for that parallel testing, Grid.
And we saw how versatile Selenium is. Simple website checks, complex interactions, data-driven testing, even those hidden shadow DOM elements.
For sure. And we can't forget waiting strategically, debugging tricks, cross-browser testing, all those come together for a really strong testing framework. Saves you time and a lot of headaches.
Whether our listener is getting ready for a Selenium interview or just learning about web testing, this deep dive was a great start.
Now that you've kind of seen what Selenium can do, what website would you be interested in testing with it?
That's a good one. I think I'd try something with lots of user interaction, maybe a big e-commerce site or a social media platform. Seeing how Selenium handles all that and makes a smooth experience would be cool.
I like that. It shows how powerful and flexible Selenium is. Simple checks to really complex stuff. Endless possibilities.
It's been fun diving deep into Selenium with you.
And with you, the listener. Keep exploring, keep experimenting, and push those boundaries in web testing.
And until next time, keep diving deep and stay curious. This is The Deep Dive.